interaction we are going to discuss more on Laplace transform. In specific, we are going to interact on wave equations. So, where these wave equations arise? So, wave equations usually we see in engineering, where mostly when we talk about fluid equations, we have different types of differential equations when we talk about wave equations. For example, differential equations in particular, we can talk about partial differential equations, because in partial differential equation we have more than one variable. So there are two differential equations, ordinary differential equation and partial differential equation. So coming again, in wave equations, why the reason is, in wave equations we come across differential, we come across the concept of differential equations in areas where rate of change occurs. Differential equations occur where rate of change occurs. So again, when we talk about periodic functions, it is continuous in nature. Okay, it is continuous in nature, and there is a flow. Again, I told you, like it can be wind flow, it can be water flow, it can be heat flow. Okay, so in those areas we can study its properties, we can analyze it. So what I could tell here is, if you can write the real-time situation scenario in mathematical equations, that is, this is called mathematical modeling. You convert into mathematical equations. If you want to find solution, if you want to find the output for this, we can apply Laplace transform over it. You can apply Laplace transform. Not that only Laplace transform is in the world. We have Fourier transform. We have different types of transforms. So Laplace transform is user friendly, but it has its own limitations. So there are some limitations and conditions where only in these areas Laplace can be applied. So in those areas we can work with Laplace transform, and Laplace transform uses integration, because as I said, fluid forms are continuous in nature. For continuous function, see, functions are of two types: discrete type, continuous type. Discrete functions are usually discussed if you want to find the mean, if you want to find the variance, all those things. We will do summation. Summation is called addition. So discrete is, for example, if I say n is equal to 1, 2, 3, 4, 5, it is discrete. N values are from 1 to 5. If I say continuous, the telling n lies between 0 to 5. If I say 0 to 5, maximum numbers are there. 0.1, 0.001. So from 0 to 5 you can take multiple values. So that is called a continuous. So if you fix an interval. So if you fix an interval, we go into the concept of integration. So integration works with continuous concepts. So summation works with what? Discrete concepts, discrete functions. So integration is also called repeated summation. Integration is also called repeated summation. Okay. So we work with the concept of exponential here. But one more thing is, if you want to work with Laplace transform, two things are very important. Okay. First, it should be in period. The function should be in periodic nature. Then it should satisfy exponential order. It should satisfy limit n is to infinity e power minus st. That limit s t tends to infinity. That when I apply the limit value, it should not be an infinite value. It should give some finite answer. Even it can be zero, but it should give a finite answer. So it should follow the exponential order. These two conditions are necessary. Okay. Even if you talk about Fourier series, there even we need the concept of that is a list of functions, a list of conditions are there, where we talk about continuity, we talk about differentiability. Even in school level, you have discussed, like if a function is differentiable, it should be continuous. But if the function is continuous, it may not be differentiable. Okay, so converse may not be true. So that way. So here, if it is a differentiable function, if you want to measure the rate of change, if you want to to measure the rate of change in whatever you see, then we need it should be continuous. For those type of functions, we apply the transforms. Thank you.